get all the response from the ground. The AT Gold can also be manually ground balanced, and if you want to go with that option, you simply press the ground balance button and release it until you see the ground balance sign come up on the LCD, and then use the plus or minus buttons here as you're bouncing it up and down to run it up until I get rid of that sound, and run it back down to where I just start to pick up a little bit of interference and then just lose it. And if I'm happy with that setting, I can click the button again and I'm ready to start hunting. The AT Gold's ground balance window is a powerful feature for overcoming various ground variations or anomalies. In the average hunting environment most people will encounter, the ground balance window's factory default setting of 2 will not need to be changed at all. Now, to demonstrate where ground balance window really comes into play, I'll go through several demonstrations here in our Garrett test lanes. The ground balance window only applies to the all metal mode. So to change the window settings, I use the ground balance push button and the plus or minus iron disc push buttons. After you change the window setting, push the ground balance button again to begin operation. Now, this test lane contains highly mineralized soil. You can hear it react. So when I ground balance the AT Gold, I have a reading of 85 on there now. One important thing to note about ground balancing, when you ground balance the detector in mineralized soil like this, it's very important that you ground balance at the search height, at the level you're going to sweep the coil above the ground. In neutral ground, there's not much penalty to this. In this hot ground where it's highly mineralized, I want to balance my coil as close to the ground as possible because that's where I'll be sweeping the coil, right above or right on the ground. My reading is 85 when I ground balanced. Now, if I stood here and ground balanced the coil several inches above the ground, I might get a slightly different reading in different terrains. So in this case, it's always going to get your best results when you got the coil ground balanced at the level where you're going to sweep it. In this case, I'm getting right down on the ground. And I've got a reading of 85 on my ground balance. Now, for this demonstration, we've added another pocket of soil here that's a different color. Both of these soils are very highly mineralized. The difference is the concentration, the level of concentration of the minerals here. But we've used a different color soil just so it stands out and you can see the variance. Of course, when you're out in the field, you're not going to have this luxury. So when the soil is relatively flat and it's the same color, you're not going to be able to see when you've passed over different pockets of mineralization. But for this test, this will make it easier to determine where the different patch of mineralization concentration is. So to test these ground anomalies that we've created here, I'm going to start with a ground balance window setting of 0. So I'm going to go into my ground balance window and drop it down to 0 from the factory default that was 2. So now I'm at 0 and I'm running like any other VLF detector that's in an all metal mode right now. Now, as I move the coil over these different pockets of mineral concentration, listen to the response. I've got the threshold up a little bit so you can hear the audio without the headphones, but you can hear a response from this different pocket of soil concentration. Now I'll use the ground balance window and I'm going to move my setting to 1 and then go back over this again. I'm only hearing just a very slight response. So if I want to go ahead and move it up to 2 on my ground balance window and go across it again, that's gone. I'm not picking up any response at all as I go across these 2 different areas of concentration. So I'm in highly mineralized ground and I'm effectively hunting with the use of the ground balance window, and I haven't had to touch sensitivity at all. I've got it right where I started out. Now here's a second demonstration in our mineralized soil lanes here. The contour of the ground in which you're hunting can actually create variations or anomalies. So to illustrate this, we've dug a little trench here. We're going over highly mineralized soil in this lane, and again, we're in the all metal mode. Sharp, uneven changes in the ground's contour, they can create more pronounced and amplified effects due to how mineralized the soil is. So again, for demonstration purposes, I'm going to have the ground balance window on this machine set at 0, so it makes this detector like any other VLF running in a true all metal mode. Now the humps and the divots in the ground, they can create abrupt responses. As the ground falls off, when I go over this little trench, you'll hear a response. So I'm going to go over this with the ground balance window setting at 0. Notice that response. This anomaly is created due to the suddenly changing distance of the coil to the soil. The more concentrated the soil mineralization, the more pronounced these contour changes can produce such responses. All VLF detectors in a true all-metal mode are going to be affected by ground anomalies. Detectors with auto ground tracking, they're still not designed to handle these abrupt changes like this. Even detectors with fast auto ground tracking just don't keep up with the abrupt anomalies. They're made to begin shifting as the ground shifts, but it's not quick enough to keep up with abrupt changes like this. So to overcome divots and humps in the hot mineralized ground like this, let's increase the ground balance window. I'm going to start by just going up to 1. Right now, we've got a strong response. I'm going to go to 1 and go back over it.